Hey everyone, thank you all for joining us again for another really fantastic webinar. This is one that I've been really excited about, and I hope you all have too. We have a really esteemed panel here to talk to you today about teaching the beam, learning the beam, and why it's such a valuable thing for programmers to learn and for people in the community to share and teach. Just before we kick off, as always, there will be a question and answer at the end of this presentation. Obviously, with so many really experienced members of the community, this is a great chance for you to ask questions and hear their feedback. So please, as the presentation happens, you can submit questions to us on either Twitter or on GoToWebinar itself. As always as well, at the end of this, you will get an email with a recording of the presentation, as well as some relevant information and links to things that presenters talk about. So stay tuned for that in your inbox. Now, without further ado, let's kick off the presentation and start by introducing our first speaker, Robert Virding.
Hi, yeah, so I'm Robert Virding. I'm one of the three original designers of Erlang, implements of Erlang. So about 1/3 of what you see is my fault, right? And the good bits, of course. A couple of interesting points in my development. One, finding out I like designing and implementing languages, not just programming as well too. And the second one, of course, was being in a situation where it was possible for me to design and implement languages and be required to do it as part of my work. That was something fantastic. The third, perhaps more serious one is, after a while, understanding that the most important thing if you're going to try and solve a problem is understanding what the problem really is. Otherwise, you don't want a solution and then try and find a problem. You have a problem. You're trying to what is the real problem and trying to find a solution. There's some of the things that have been fundamental, I'd say, in my development.
Hi, my name is Michal Slaski. I learned about Erlang while working on my thesis project, and then I went on training with Francesco, where I learned about Erlang Otp, its conventions, its design patterns, and this training with Francesco gave me a jump start to my career at Erlang Solutions. I then went working at customers first as a programmer, then as a consultant, and after several years, I started to deliver trainings myself. 10 years ago, I set up a new office of Erlang Solutions in Krakow. I co-founded also a conference because through Erlang, I got introduction to functional programming, and I fall in love with this paradigm. So I co-founded the Lambda Days conference, which focuses on functional programming languages, and we can meet. There are many other founders of other languages, spread the love to Erlang and Elixir, but also learn more about the other languages which have been founded on similar paradigm. I'm looking forward to this session with others. Who is next?
I'm next. So it's funny. I think that I'm the only one on this list that wasn't born a functional programmer, if that's a thing, right? So initially, my first job was at IBM, and I was coding Java. And so then I moved on to a consultancy where I coded Ruby, right? And then I got an inkling that there was something else out there. So Robert, I was looking for you for a long time, and wrote a book called 7 Languages in 7 Weeks. And that kind of started changing things for me. So through that, I found Joe Armstrong, or he kind of found me. He was sent a copy of the book, actually before even all the typos were out of it yet. And so my editor sent him the chapter on Erlang and the chapter on Prologue. And so it was a pretty scary review, but that kind of opened a door. And then Francesco saw that book and invited me to come to Stockholm and actually speak, and that opened a lot of doors for me. So so after coding Elixir for a little while, I have used Elixir in production for about 7 years or so, I guess, if from 2012 on. I guess that's 8 years. And So since then, I've founded a company called Groxio, and I call that career rocket fuel for curious coders, right? So the idea is that we can support programmers as they learn and grow. And I thank Francesco and Robert for all your work in this, and it's really a joy to share the panel with you.
Right. Thank you, Bruce. It was great being on a webinar with you. I'm Francesco, the founder technical director at Erlang Solutions. I started my career as an intern at the computer science laboratory with Mike, Joe, Robert, and Bjarne. And then there's a picture of me with my Beatles haircut, which I think we kind of notice is not very different to haircuts you have during lockdowns. My first project was I worked on the very first release of OTP, the R1 release of OTP. I co-authored two of the Riley books on Erlang OTP, Erlang programming and designing scalability. And what I enjoy doing the most is, well, two things. One is architecting system with no single point of failure, which can scale to the requirements of the customers. And I've also helped, I think, over 1,000 people make the transition to Erlang professionally or academically. So through training, yeah, again and again.
Cool. Thanks for that. I guess now that we've met and introduced the speakers, I think the best thing to do is to hear their stories on why they love the Beam and why they love teaching it and why they think that's important. So we'll start off with Robert and give the panel a chance to sort of present theirs and talk to each other.
Okay, so for me, it's all about the concurrency. This was the thing that really distinguishes Erlang and Elixir from other languages and systems. It's the fundamental feature of the Beam going all the way down for it. And when you're looking about training, I mean, you'll typically be using libraries that might hide it for you, but it's there. It's always there in the bottom, and you actually need to know about it if you want to be aware. You need to be aware of it if you're going to build fantastic systems, right? That's you can't get past it. I mean, you might be using say libraries like OTP, which are on top of which hide it. You don't see it, but it's there, and you have to know about it. That's a fundamental part of the training. The second thing there is after the concurrency is next slide.
Before we move on, I just wanted to add one thing here, because Joe Armstrong once said that you can copy the libraries, but if it does not run on the Beam, you cannot emulate the semantics.
No.
This is why I love to teach the Beam under the hood, where we dive deep into the Beam. What makes the Beam so special? I just wanted to quote Joe Armstrong here because I think this one is relevant to this context.
Oh, yeah.
Robert, sorry to interrupt.
Yeah, it's the Beam all the way down, right?
And I also.
Yeah, so I was just talking to a few people on LiveView, and coming from a team that worked on the Ruby on Rails project, I really appreciated Ruby for the things that it did well in making programming more accessible in some ways. But one of the things that I noticed was that there was a movement to jump to the top of the problem that they were solving, right? So there's this thing called action cable, which has to be really concurrent and really, and it enables some sweet things on the user interface. But if you haven't done all of the work on the concurrency, like you said, Robert, and also all the things leading up to that, it's all for naught, right? So what you saw out of the Phoenix team and out of the, coming before that, the Elixir team, and coming before that, the Erlang team, and coming, all the way back to your initial team that was deciding what problem are we trying to solve.
Yeah.
All of that was building these steps on a pyramid till you got to the top. And then Phoenix LiveView seemed really easy because the hard work was already done.
Yeah. You need to know about it. Well, if you know about it, it's fine. Then you don't have to call it, but you know what's going on underneath, right? I think that's the important thing.
And I think, sorry to interrupt you here, Robert, but there's what I believe is called Robert Virding's first rule of programming, which states that any sufficiently complicated concurrent program in another language contains an ad hoc, informally specified, bug-ridden, slow implementation of half of Erlang.
Yeah, that's taken from Greenspan. He did it for Lisp, I did it for Erlang. But yeah, you end up copying for it. And I think the other half of it is the error handling. I mean, we tout and we train and we tell people and show people about how to build fault-tolerant systems. But this is based on top of the error handling mechanism for it. In the same way that everything's on top of the concurrency, everything here is on top of the error handling, and you really need to know what's going on. You might never actually use it, but you need to know how it works to do things for it. And they're the bases I see for training and what's going on.
I think, Joe.
Sorry about this.
Joe. Yeah, so good.
Yeah. Well, you had something there, Mike. Francesco.
Yeah, I think Joe once told me that he realized that if you needed a process monitor another process, you needed concurrency, and it's actually concurrency which makes all of the error handling possible. Yeah. And Mike Williams, the third Erlang inventor, had a very similar story where one of the very first cell phone systems, they had a person staring at a screen 24 hours a day. Not the same person, of course, but whenever they notice a system crashing, which you notice through a lot of kind of text and garbage in your shell, they would go in and restart the cell phone system manually. And basically, the single-threaded mobile application, cell phone application, was one process, and the human was the second process. And I think what Erlang did was automate all of this. Yeah.
You need to think it through, then you can do it, and well, there's a lot of support for doing it. Yeah, this picture, that's actually me at work. That is not me playing. Well, I was enjoying myself, but it's not me playing. We needed something to show at a trade show, and showing a small switch basically was nothing. If you look behind my screen, you see a little box with a few cards in it. That was a switch we had in the lab, and at most it was a red light that came on when you turned it on, right? So we needed something, so we thought we'd make a train set and have it being controlled by Erlang. I went
so
slightly
you were playing,
overboard.
right?
Sorry?
So you were playing, right?
No, this was serious work, right? This was serious work. I ended up doing an automatic train control system, so you could program where the trains are going to make sure they never collide and anything like this. It took a bit of time, but it was fantastic. And it worked very well for Erlang. It was something we'd never thought of before, but it worked very well for this.
Robert, isn't that the phone switch? Isn't that the phone switch which was actually being used in all of the first training courses at Ericsson?
Yeah. The first training courses we gave at the lab, that was a switch we plugged in to use. It's only it's a small Ericsson PABX, but that's what we were using. So again, this is attacking the problem. From the very beginning, we were actually controlling real hardware and doing things for it and getting feedback if it worked or not. So yeah.
And for those who did not attend the course, basically the very first Erlang training course at Ericsson, that indeed came in not knowing a line of Erlang, and 4 days later they walked out having written the PBX software, which allowed them to make and switch phone calls. I think you could attach 4 phones to that switch, if I remember correctly. And it brings the whole from 0 to hero.
Wait, keep going.
Yeah,
I'm still here.
Yeah, so
I don't have a car outside my window, but there's a helicopter. But yeah, same effect. So we're back.
So I wanted to also share another angle on this. Over the last 10 years, I created, trained, and consulted teams of our customers and also within our organization. And I learned that a small vocabulary of Erlang makes it a language which is easy to maintain because there are not many different programming styles, which in a bigger team is a plus. I like the quote from Robert's keynote that called Beam Virtual last week on the effort we put into removing unnecessary constructs from the language in the early days of the language design process. I have also similar thoughts on Elixir, which seems to have larger vocabulary, but is intentionally kept not too big as a language by Joseph Alim, and which limits the number of ways in which one can solve a problem. The Elixir maybe is a bit more complex, streamlined for writing, while Erlang requires more writing, but is easier for reading. That's my personal observation here. But as a result, there are not many different programming styles, and this really helps.
Yeah,
it makes it much easier to understand what other people have done.
Absolutely.
To understand the system, because there's not so much strangeness in there. And yeah, again, so it took a bit of effort, and I know Jose did the same thing, but it took a bit of effort to do it. It wasn't trivial. But yeah.
I know, I personally love what Jose has done, with Elixir and the ecosystem around it, making approachable and accessible to a whole generation of programmers who did not grow up using VI, Emacs, CBS, or well, even phone switches, and it really has helped, bring the whole Erlang ecosystem to a whole new level. So yeah, kudos to him. Yeah.
Yeah, it kind of strikes me that that a big part of a successful language is not just knowing the notes to play, right? If you're a great blues player, you know the notes not to play.
Yeah.
There has to be air in space to kind of take things in. There have to be, intentionality in the structure, so that if I'm blues, I'm playing flatted fifths. If I'm country, so on and so forth. So I remember being at Joe's house when he was learning the jazz piano, and he says, well, scales don't work like this, they work like this. But he approached that the same way that he approached building the language. And I think that it's brilliant that the whole Erlang team came together to understand what's working and what's not working, and thus not polluting the language at a pretty early time. And I think that set the stage for later success.
It took a lot of effort, and I don't think sometimes Mike was impressed by what Joe and I were doing all the time.
You asked Mike, what did you contribute, most to Erlang, and his reply often is, "Oh, I spent most of my time convincing Joe and Robert that we didn't actually need these features because they didn't add anything to the language." And I think he was successful in what he did. Yeah.
Yeah, he was that. He also did a lot of other things as well too. I mean, he's the main person behind the error handling mechanism. So yeah.
But it really goes to show it was a winning team who invented Erlang, and each and everyone had very different qualities, which put together created was a catalyst for what we're still using today, 30 years on, and making something which is way ahead of its time. Yeah.
So this is still relevant today. Having a small language with widely adopted conventions helps, from my experience, onboard teams, hand over projects between teams, and scale development organizations as such.
Yeah, most definitely.
And I kind of realized, actually, when I was at Erlang Systems, Ericsson, because I think, Michal, what you just described is one of the requirements they had, and it actually reflects how Ericsson ran their projects. So it might not have been part of the language specification, but I'm sure it indirectly influenced the language, or to quote Rich Hickey, Erlang is the language of the system.
Yeah, I think that, go ahead.
Well, I'll just say, I mean, we realized, decided, it depends how you want to see it, to try and keep the language as small as possible, and put the effort into making sure that the base constructs are simple in the right way. And
I completely agree with that sentiment. It's especially since there are so many big concepts that you have to learn when you're going into Erlang. So you have to have the minimal set right. You're picking up concurrency, you're picking up this thing called OTP, you're picking up often functional paradigms, and all these things are big mental jumps. So when you start with a minimum set, that makes everything much easier to absorb.
Yeah, so
I can just sum up here. So why do I teach the Beam course? I teach because I think the Beam is undervalued, by which I mean we can only learn about its benefits and appreciate them from a longer term, when we run them, maintain systems, when we have to inspect live systems. I dive deep into the Beam, to highlight all of those interesting features of the virtual machine and how you can take advantage of them throughout the whole life cycle of a project.
Yeah, yeah.
Bruce, how about you? Why would you?
A lot of stuff underneath there, yeah. So
Bruce, how about you?
Yeah, so I think that the Beam is especially approachable, and that might be a strange comment after I said how many new things that you have to learn when you're stepping into the Beam, which might be for me more of a Elixir or for Erlang developers, more of an Erlang type move. But I think that there are two major things that are happening here, and one of them is that to be approachable, you have to have a lot of the things that Jose added to the Elixir language at a pretty early age. I think that one of the cool things that's happening right now that's leading to a resurgence in the Beam is that we brought many of the ideas from really a commercially successful language that really got a lot of the adoption things right. And we kind of mixed in all of the underpinnings that Erlang did a tremendous job getting right. All the things that we talked about, the error handling, the clean concurrency constructs. But so having that approachability is really big to me, because when I'm teaching developers often who haven't learned any language at all before, they can start to sink their teeth into something where there's good documentation, where there's very simple constructs that serve as building blocks for other things. And the second thing that's really interesting to me is that one of the primary abstractions, the OTP abstraction, is so simple and so brilliant. It really makes the hard problems easy. So one of the things that I've noticed is that through my career, I've moved from teaching the easy problems, which now you read a couple of blog posts and you have them, to basically managing the hard problems. Now, Erlang and Elixir don't necessarily make the easy things much easier than like a Ruby or a Python, but they make the hard things a lot easier. And so I can, a little anecdote here. I was teaching a OTP class, and there were maybe 5 people in the class, and that's it. And we were flipping the keyboard so that I wouldn't code at all. I would basically ask people, I would, kind of show a concept and then ask them to write the code and ask them to help each other as they coded it. And we had a little bit of problem with the functional core, right? The pure functions, because these concepts are pretty difficult, but we shaped the code in the right way, right? We built a reducer. And then when it was time to plug into OTP, everybody just got really quiet for a second. And I said, what's happening? I've lost this. And they said, wait, that's it? This is easy. OTP is easy. They kind of got the, so it was really cool. And then so I always try to get a lot of feedback when I teach the Beam, right? It's because there's a lot of things going on. It's like, how's the pace? What are you learning? What do you not like? What do you like? And every single person was saying the same thing in a different way. The core, when I had to shape it right, I had to extract everything, it made me think a lot harder first. And when I did, everything was so easy. And this is just a testament to the brilliance of the programming model of OTP. That's just a message loop and messages coming in, feeding state in on the outside, put that aside, and then something that's a process manager, right? It knows how to start things cleanly, it knows how to stop things cleanly, it knows how to restart, and it knows how to detect failure. So it's basically a lifecycle manager. And everybody got it after one day, this big OTP beast. And they were just stunned into silence. It was a joyous teaching moment.
Okay, yeah.
So
Francesco?
So one of the things that I like to talk about is metaphors for OTP and for life, right? And so we just talked about the idea that one of the things that I do is I try to give things names that are approachable in the beginning. Like the supervisor, I say that this is something that manages lifecycle, right? Of course, it supervises, but when I bring up the documentation, a lot of the language, children, starts, stops, restarts, that's about lifecycle. And so when people say, well, give me an example, give me something to read, give me something to watch. Sometimes I will send a student to this cheesy British comedy called The IT Crowd. And it's about 3 customer support people that work down in the basement. And, basically they'll get customer support calls all day. And they'll ask the question, did you try turning it off and on again? Why? Because it works, right? Software works the same way. I mean, we've been able to achieve these tremendous reliability metrics simply because we have a clean programming abstraction, clean concurrency, clean lifecycle management, clean error handling, and then basically we could try turning it off and on again, and most of the time it works. And when it works, we turn it off, we turn off the children cleanly, we bring things back up in the reverse order cleanly, and it works. And it's a marvelous thing.
Yeah, I know. It's sometimes I think it's too easy.
Sometimes, right?
Yeah. Well, I mean, if it's too easy, people sort of start wondering what have they missed, right? But sometimes they haven't missed anything.
Yeah. So one of the things that was interesting is we kept getting this at the beginning of classes. We would hear the question. I would ask, "What do you want to learn?" And they would say, "Well, I want to learn OTP." I said, "What about it?" "Well, just OTP." And it became clear they didn't know anything about OTP. They were afraid to approach it because all of the things that it does, right? It's not all the mechanisms. The mechanisms are simple, right? The core things that you use, maybe half dozen functions most of the time, maybe a dozen, to really get most of what we access. There's the code side in the gen server, and there's the policy side with the supervisor where you bolt on a little bit more code. But yeah, there's really not much there that gives you all that value. But people start to think about OTP is this thing that handles failover and supervision, and they just don't want to look inside and see how it works. And so when they get that moment, that's why we teach.
It's beautiful. I agree, Ben, and I think more often than not, I've also based on what you've been saying, experience that the saying that if it's too good to be true, it probably is. But in this particular case, it's we've had a hard time convincing people that we're actually telling the truth, and the only way forward has been to demonstrate it. So yeah, why do I teach the Beam? Why do I teach Erlang? I think what really attracted me to the language is the fact that it changes the way you think and reason about programming. And the biggest challenge in learning Erlang and Elixir is actually unlearning all of the bad habits from other programming languages you have and to start thinking concurrently. I think the very first course I taught was back in 1998, and I had a class which did not want to be there. They thought that Java, which was the cool kid in town back then, was the best thing since sliced bread. And there was a very young me there thinking that they must have had a really, really traumatic experience learning it, and learning Java, that is. And I was actually thinking that they believed that any other programming language was going to be as traumatic. And I had 3 weeks to turn that class around, after which they needed to become productive and start the handover of one of the very first Erlang projects, the mobility server. And I think my challenge the very first time I taught was how to tell the students that learning a language which does not change how you think and reason about programming is a language not worth learning. And it's and that's Bruce, what I love about your book, 7 languages in 7 weeks, 7 languages, 7 approaches. 7 different ways of thinking and reasoning, all of which brings something to the table. And I think learning the concurrency-oriented approach in Erlang and Elixir will make everyone a better programmer, even if they're not using the Beam, even if they're not using a Beam language on a daily basis. And that's really what I like. I don't teach Erlang. I teach my students to become better programmers, regardless of the discipline which they decide to move forward with.
Yeah, it forces you to think in a different way and look at problems in a different way, and hopefully they learn something new about this, how to look at the problem, even if you have to go back and write it in the Java language. But you might rethink how you write things, how you structure your system, and get different features and different properties out of it.
Yeah, so it's really interesting. I have this thing called Programmer Passport, where we basically, the idea is that we break developers down on a regular basis and build them back up, right? And so one of the things that we do is we go from language to language. Well, so we're going to go on 3 different sessions, all within the Erlang ecosystem, right? We taught Elixir, and now we're going on to OTP, which is its own programming model itself, right? And then we'll go into live view. Well, not just live view but basically this idea of event sourcing and building that on top of OTP and streaming events back and forth. But one of the things that you said that really resonates with me, Francesco, is this idea of unlearning. So one of the reasons that Groxio exists is that I was at a conference. I know that you think the same way, but I was at a conference a little while ago, a functional programming conference, where we're basically training the future. And I noticed that there were a whole lot of middle-aged white guys in the room, and it threw me off a bit, right? So I think that maybe we're at a point in history where paradigms are changing and people are starting to recognize the value of concurrency and the hard things, and you have to unlearn the old things to learn the new things. And so this is a tremendous opportunity to invite others into this world that haven't participated for a long time, if ever. And that's really keeps me going as a teacher and keeps me excited.
Okay.
I think concurrency actually leads, your words on concurrency leads me to my quote, which is from Joe Armstrong, Joe Armstrong's tenets or rules. And what they do is they describe the world around us. The world is concurrent. We as human beings are, we're all kind of individual entities, and we, things in the world don't share data. So the 4 of us don't share a brain. We all each have our own individual brain, and we communicate with messages. So I'm right now telling you a message. I'm broadcasting it to everyone listening, and everyone will take in whatever parts of the message they need. They'll parse it, and they'll retain what they think is relevant, and throw out what they think is irrelevant. And things fail. Sometimes
you're not going to fail the presentation out as a demo, are you?
No. I won't fail the presentation. No, but things fail. I can walk out here and be hit by a bus tomorrow, or I could be taken to hospital and recover. So even though not the time to end up in hospital, but yes. So things fail, things do recover. And I think how do you create a language describing this natural way of thinking? Model this in and what you guys did was you modeled this programming language, which was invented to solve a particular problem, but you modeled it based on a natural way of thinking. So when we say that we need to get people to unlearn what they've learned, the only thing we need to do is to start getting them to think in a natural, concurrent way. And it's something which I think this concurrency I think is critical to where programming is heading in the future, or more than that, a concurrency based on no shared memory, because you need a concurrency model based on no shared memory for distributed programming. You also need that to scale multi-core architectures. And so every system we interact with today is concurrent, and it's distributed. So it's this is the future. The Beam and Beam type languages are the future.
Yeah. So we've been spending a little bit of time on the water, right? And the bigger the boat, the harder it is to turn, right? So there's this big old ship going down the channel, OOP, and it's turning. And Francesco talked about exactly the reasons that it's turning, right? It's there was the paper in 2010, the free lunch is over, right? That talked about we can't keep shrinking things. We've run out of atoms, right? And then so we have to stack the chips, and when you stack the chips, each one of them has its own concurrent process on it, and so you can't think in a single threaded world anymore. And then the problems that we're solving, the Internet of Things, right? So you don't want to break your thermostat because you had a bug in it. You have the single page apps, which they want to be concurrent. So it's a concurrent world. This big ship is turning, and it's really excited to be invited into the middle of this conversation.
Yeah, but it's taking its time. It's not going fast. But I mean,
yeah. I remember.
I find people usually grasp it, even if they're coming from a different background. I think, well, you guys as well who also do training, people do get it, right? Yeah, they have to rethink and accept the fact that this is not what they're used to, but that they get it.
And you have to invest, right?
I really want to quote Guy Steele here because I spoke right after him at the conference, and I was sitting front row, waiting for my turn, and speaking after Guy Steele was a bit daunting. But there he was talking about Fortress and the whole point that you need a new mindset. You need a new mindset, and when dealing with multi-core architectures, and this was about a decade ago, and there I was, jumping up and down, really, it was the best introduction he could have given to my talk was, thank you, Guy. We need a new mindset. We have this mindset. Here it is. And off I went and introduced Erlang and the approaches we've got, to multi-core architectures, which is basically, think concurrently, do things the way you've always done, and with a few caveats, what you have will scale on multi-core machines.
Yeah. But Michal, what do you see in the functional conferences, the functional conference you hold? That's also maybe also a lot of new stuff for many people, wouldn't it? Perhaps not the concurrency, but the functional side of it.
But also actually with concurrency in mind, because the functional programming community is trying to look for case studies, some stories that we can tell where functional programming was really applicable, when did it help. And it turns out that this particular paradigm helps to abstract away concurrency and parallelism in a way which helps you think about it, model this first, and then also scale on hardware or on platforms that you run it on. So when we get to hear from also other language inventors, quite a lot of time they put emphasis on parallelism and on concurrency. There is also a question then, if many languages claim that they can support concurrency programming, concurrent programming, why would you want to learn one of the Beam languages? And for this one, when we have such discussions during the conference, I often point them again to look at the VM, the underlying virtual machine, which gives you such interesting properties like tracing, like being able to observe a system which is live. And again, people can argue that other languages may be a bit more efficient in this or the other aspect, but when you need to maintain a system for a longer time, the ability to look into it as into any other operating system, inspect your running program, again, the same way as you would inspect running processes within your operating system, this is really a differentiator. And apart from the right paradigms of the programming model, those semantics of the underlying Beam are really interesting and unique. And this is my answer to the question, why would you want to learn one of the Beam languages then? Which maybe, yeah. Mm-hmm.
Yeah, I quite agree. Just one interesting point there, you're mentioning the tracing in the Beam, which is truly fantastic, what you can, how you can trace things. But if you look at it, it's also extremely simple. I mean, there are two primitive calls just running the tracing, and both of them are extremely simple. I don't know how, but they got that so right in some ways.
I think these are all the
I
lessons.
wasn't part of that, so it's not my fault. But they just
These are all
got
the
it so right.
Robert, these are all the lessons from the XC10 switches and actually monitoring and and maintaining them, and which fed into then fed into the Beam and into the into Erlang and any languages which are now deriving from Erlang and Elixir. Yeah.
Well, we were quite happy to steal ideas from anywhere. We weren't very specific about that. If we had a good idea somewhere we could use, we took it. Right?
You did a very friendly thing of recycling. That's what.
Okay, we'll call it recycling. That sounds better. But yes.
So I have a comment. I was listening to Michal and Robert, and Michal, you were talking about the idea of layering abstractions on top of concurrency, to Robert's question about concurrency. And it made me think of my days in the Java world. And I knew that that Java was first not going anywhere, and second, in a little bit of trouble in terms of complexity, when I saw that there was this single, well, let me tell the story with a metaphor. So in the United States, we have this this old 50s TV show called The Andy Griffith Show. You guys seen it?
Yeah.
And there's Deputy Barney Fife, and he has a gun, and they only ever gave him one bullet for the gun, right? And so object-oriented languages are languages with one bullet. You can apply your inheritance to a single dimension. And once you've fired that bullet, it's gone.
Yeah.
Right. So one of the tools that functional languages can provide is this brilliant way of layering across multiple dimensions, right? Especially with Erlang and the pattern matching, I can pattern match across any dimension that I want to. And then when you layer on the type ideas in Elixir, like for example, the protocols, and then you have the Erlang ideas of the behaviors, then you start to be able to extend across whatever dimension, whenever you want to, at the right layer of the system. So it's really fun to kind of be part of this conversation and hear, well, why does this work? And so I think that one of the questions that would be interesting to our audience is, where are some of the places that we see difficulty teaching on the Beam?
Cool. I think we'll get into the Q&A off the back of that, and hopefully if anybody in the panel, in the audience has a question on that, they can provide something more specific. So we do have a number of questions for you guys. Sorry about this. We get back into, sorry about that. So we have a number of questions. The first one is, what are the major hurdles people find when learning Erlang and Elixir?
So
I see two. One is the functional nature. It just coming from an OO background. It's yes, it's simple, but it's very different in many ways. And that's not too bad. What is worse is just thinking concurrently, splitting your problem up into thinking of processes and working with processes, things like this. That I think is more difficult. It takes more time for people to grasp it, and to understand it and get around it.
Yeah, so I think that we tried to address this question in designing Elixir Systems for OTP, which, by the way, isn't really Elixir specific. All those ideas could be based on Erlang as well. But one of the things that we try to address is that fundamentally the resources that you're trying to preserve are different. Right? So with object-oriented languages, with procedural languages, we tried to optimize the memory footprint from the very beginning. And with functional languages, we're not afraid of making copies. And in fact, we have to make a certain number of copies. So really understanding the trade-offs of the data structures in a functional world versus an object-oriented world are very different. So, and then there are other resources as well that we need to be aware of. Like I talked about the object-oriented idea that you have to be really careful where you apply your inheritance. That's not a resource that we care about at all in the Erlang Elixir space. A process, I have to be really careful. 50,000, maybe a few more in the Java world. I could get hundreds of thousands without breaking a sweat in the Erlang and Elixir worlds. So I think that understanding your resources is one of the problems. The second problem that I see is that we really have, when we think about how things are constructed, about the glue that's between the main entities in a language, you need to think about composition. And object-oriented developers are used to thinking about composition in a certain way. So the idea is when you take away the object-oriented composition, you need to replace it with something. And I know Francesco and I have talked about this. A big part of it is the concurrency and the message passing that lets things communicate. And in the Elixir, with Elixir programmers, we often teach pipes very early, and we teach the ideas of, okay, this is a pipeline. It's constructor, reducer, 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 transformer, reducer, reducer, right? So these forms of composition really make things easy, make it easier to build layers, which is really the essence of programming. How do you take all this complexity and only expose one tiny sliver of complexity to the user at any given time?
So so I need to just to add, to this. I think my approach to teaching is, by explaining why I teach how, and in my view, there are usually 3 hurdles which students tend to stumble upon, and these are actually hurdles which you barely need when you move on and use OTP, but in my view are fundamental and critical to making the most out of OTP. I mean, the first hurdle, I mean, that comes from pattern match. That comes from the functional paradigm, and it's pattern matching. And being able to really understand pattern matching, because what it does is it abstracts your code and really reduces the size and the amount of what you write. And it's not hard, but it takes a little while getting used to it. And people, then at that point, really go in and understand and realize, the value of it. The second is recursion, and again, it's something which I don't think is taught as much as it should in the Elixir world, which I really make sure that my students leave the day with a head hurting, but being able to implement recursive exercise in recursive functions and understand which patterns to apply. And so before using the libraries, learn which patterns, recursive patterns to use and how they work, and the difference between tailed recursion and non-tailed recursion. And then with those 2 things in bay, the third hurdle is understanding and thinking concurrently. And that really has, thinking concurrently. And then that really is, what we covered the second day. And so, all of the hard parts, are covered in the first 2 days of the course, after which everything else will just follow. And it's just consolidating on what everyone's learned. So, and I think, let's get rid of the hard part first. And, once we've learned all of that, everything else will follow. Let's have fun, and that's kind of, I think, very much the Erlang mindset.
Cool. The next question we've got is one that I've seen quite a bit, which is how has Kubernetes influenced the role of Erlang? Do we really need all of the tooling that goes along with OTP, or can Go handle some of those more specific purposes? And has Erlang become more of a Swiss knife of backend languages in that regard?
Duck.
So I actually spoke about this. I I spoke about, there's a code beam last week, and you should go in and look at the talk I gave with Veronica called The Future of Programming. And I think, Veronica is on the Kubernetes core team. She handles all of the releases. And our conclusion is kind of in the future, one of the problems with Kubernetes today is that it's people are using it for things it was not optimally implemented to do. And so it's almost, but things which the beam has been doing for a long, long time. So it's almost like, we've taken 2 steps forward and 1 step back. And if we look at where we're heading in the future, I think it's going to be very much, I think Kubernetes, with the types of system we'll be solving will be there, but it should not be visible to the programmer. So, Kubernetes should be there controlling our infrastructure, controlling how, where, we do and run things. But it shouldn't, the programmer shouldn't be, shouldn't know it's there. It should be there to make life simpler for the programmer, and not, vice versa. And so, I think it's a very important part. But if you think of, Kubernetes, what does it do? It starts containers, it sends messages to containers, it monitors containers, and it stops containers. I get a sense of deja vu, which is a supervisor, but on a slightly larger scale. I think very much, the future will be the coexistence. You also mentioned Go, and I think, we need to use languages for what they're good at, and for what they were originally intended for and built for. And so, that's what you need to, when you're developing a system, it's not one language or the other. It's more, how do you use languages? How do you use languages together?
Yeah. 2 points there. One, I think Kubernetes is much coarser, much bigger units than running anything on Erlang Elixir. I mean, if we're sort of nano tasks, and they're sort of mega tasks type thing between for it. And this was Francesco ended up saying, I personally don't have any trouble using multiple languages. If you have, most large systems, there are different parts with different priorities and different needs. Pick different languages. If you have something that needs some serious numerical calculations, pick the right system to do that. I don't care what it is. I just plug it into the Erlang system, and that you do the concurrency, and for other things as well too. I mean, why worry? I can't get worked up about it. Well, I can get worked up that people get worked up about it, but I cannot myself see any problem with using multiple languages for it and putting them together. And that's getting back. The Beam has some nice ways of doing that, of plugging in other things and do it when you need it. Fine.
Getting worked up about getting worked up is the most meta thing you've ever said, Robert.
Yeah, well, I'll try. I'll get unworked up. Okay, so next question then, perhaps.
Yeah, question.
Cool. Next question was, is the Beam relevant to WebAssembly?
Take that again, sorry.
Is the Beam relevant to WebAssembly is the question.
So I can take that briefly. I think it's a bit out of context, but it's going to be, I think it's going to be really interesting to see how Lumen works out, which is basically a WASM implementation for the browser. I think WebAssembly should be taking on a lot of the properties which today the Beam has. So they should be focusing beyond kind of JavaScript and the browser and start thinking concurrently. It's only then I think will the two become much more relevant and much more tied together. So I think it's still very early days to answer that question, but I'm personally following what's happening in that space very, very closely. But we've seen lots of things, lots of technologies come and go. Some have made it mainstream, some have found their niche, and others never made it. And so I think, it's very, very early days. Very, very early days to know that.
Cool.
answer that. Yeah.
So the next question is, how important is it to understand advanced category theory concepts like functors, monads, and natural transformation to be able to program effectively with Erlang and Elixir?
Not at all. Not at all. Like I can quite
Robert,
confidently say that. I've never really learned the theory side of it. So from that point of view, I'm a terrible functional programmer. But you don't. I think in many ways you don't need to just know the theories. That's my personal opinion. I'm probably riling up a lot of people now, but I don't think you need to do that.
So on the scope of things, there's more static typing and more dynamic typing, and static typing basically allows the compiler to do more of the work at a cost, right? And some of that cost is complexity. So you get to make a decision of whether you want to take on that additional complexity of functors and category theory, or whether you want to kind of loosen that complexity, and you pay a little bit of price. But that's basically a programming trade-off.
Yeah. This question reminds me very much of an argument on conf.lang.functional, I think, in 1996 or 1997, where Erlang was being spread out in universities, and I think some academic went in and said, "Oh, in order to understand Erlang, you need to understand Lambda calculus." And Joe Armstrong went in and says, "No, absolutely rubbish. That's not true." To which the person insisted, "Yes, you need to understand Lambda calculus. If you don't understand Lambda calculus, you can't understand any functional programming language." To which I think Joe went back and responded something along the lines of, "I invented Erlang. I do not know Lambda calculus. If I don't know Lambda calculus, you don't need to know it either, And I think the same would apply to pretty much functors, monads, and all of these other kind of weird constructs out of which are applying to functional programming. So no, you don't need to be a functional programming guru or expert to pick up any of the Beam languages. Opposite, they make functional programming much more approachable.
Yeah. I quite agree. Yes. Yeah. Well. Yes.
Cool. Another one. This one's I imagine a little bit simpler. What is the best book for learning Erlang and Elixir for a new developer who has a technical background?
Okay, Erlang. I'll take Erlang. Obviously, it's Erlang programming. It's the Kangaroo book, which I warmly recommend. It's a book I co-authored with Simon Thompson, and I think it came out a few years ago, but it's still very relevant, and it goes very much in depth into Erlang and the rationale around Erlang. So it really tries to explain how to think concurrently.
An alternative is Learn You Some Erlang.
That's another great book. It's available online.
Book.
Yeah, that's another great book.
It's also fatter as well too. You get more pages. It's very well written.
It's
the only thing you should be aware of, if you start looking through it, it's full of funny stuff, jokes and things like this for it. But don't be alarmed by that. The content is very serious and correct, right? So Fred might make a joke about something, but he knows very well what he's talking about. So yeah. Francesco's book's more serious.
And I think there's a third book, which is Joe Armstrong's book, which is Programming Erlang. So not Erlang Programming, but Programming Erlang, and it's editors who and I think all three books are very complementary of each other. So it's all three books take different approaches and explain things in a different way. So yeah.
And the Elixir side, I don't know what you have there.
Yeah.
Dave Solis' book is one place to start.
Yeah. So I think that probably I would recommend a couple of books. So as a technical developer, probably the starting place is Dave's book, and then I would probably follow it depending on whether you wanted to do web programming or whether you wanted to just take a step forward in the design of Elixir Systems. I wrote a book with a man named James Gray, who's one of the most brilliant programmers I've ever met. And we wrote a book together called Designing Elixir Systems with OTP, basically to fill this gap, to basically say, okay, now you know how the language works, you know what the constructs are, where do you put the layers? What are the layers and where do you put them? And how do you do that in the context of OTP, in the context of a library, in the context of a dependency? So those are the two that I would start with.
And once you've done those two, I actually, it's my second book, Designing for Scalability. A large number of readers are actually from the Elixir community, even though it's written in Erlang. I'm using Erlang. It's Elixir community has been one of the largest adopters of that book, because again, if you really want to understand how the internals work, again, by explaining why, I show how, and again, that took several years to write and put together, but it basically puts all of the experience we've had of working with OTP for the last 20 years in about 450 pages. So
I agree.
Next question. Right.
Cool. Next question is, I'm recently introduced to the Beam programming languages, and I'm wondering what will make me learn yet another programming language? What reasons do you see to learn a non-Beam language in the future?
So you never stop learning, and I think Beam languages are great, but you need to use the right tool for the job, and it's not always the Beam. So keep on learning, keep on trying new languages, because again, it's not so much about a single programming language, it's how you use and interact, use different languages for what they were originally built for, and leverage their strengths.
I believe that the most important the most important skill that any developer has is the ability to learn. And to effectively do this, you have to take yourself all the way down to a novice level. So, Groxio, we have this thing called Programming Passport. There are all kinds of great books for learning new programming languages in a different way. But one of the things that I did recently is learn the Pony programming language. And so Pony isn't this real soft, fuzzy language that you get by just understanding a few syntactic rules, right? It has some fundamentally different things about the way that it approaches typing. Like, for example, what do you do when you're trying to eliminate runtime errors? What do you do when you're trying to eliminate the divide by zero error, right? Well, one of the possible answers, it might not be the answer that you would choose, but one of the answers is to always return zero, right? And so there's a philosophy around that makes you think. You might not agree, but it'll make you think. And then also this idea of reference capabilities. That's a capability. That's a language feature that allows Elixir to be used, allows Pony to be used in such a way that it has shareable, readable, writable memory that can be shared, because if you break the rules, then your program won't compile, right? So it has this kind of rule checking that's really cool. So yeah, learning for the sake of learning is a valid reason to learn. You're going to improve yourself, make yourself a better programmer, and make yourself more valuable and adaptable.
Bruce, my turn to ask a question now. We've got the audience asking, but I want to ask Bruce, how has Pony made you a better Elixir programmer?
How has Pony made me a better Elixir programmer? So basically, I think about things in terms of what Elixir can do and what it can't do now. I spend more time thinking about, okay, well, if I was doing this in Pony, then updating something rapidly wouldn't be a problem. So I actually spend a lot more time thinking about my Elixir data structures in ways that I can build a system where I'm rewriting the smallest piece possible. So, for example, if I have a deck rather than a queue, what data structure would I use to kind of save the copies? And so there are a number of libraries that do these kinds of things, and kind of digging in those code just for the purposes of digging into them has been great for me.
Right. And I think that answers the question, why should I learn something new? And also answers why, I love explaining the beam, which I said earlier, because it changes the way, people think and reason around programming, irrespective of the programming language they use on a day-to-day basis. It will make them better programmers.
Yeah.
And that's why you keep on learning and keep on reading, keep on looking and discovering what's out there. I mean, Michal started Lambda days, I started Code Mesh. We both did it in a quest to continue learning and discovering, learning new programming languages and understanding more about what's out there, but also understanding the history, because it's the history which has brought us to where we are today. And these new languages, are coming in and are forming the history under our very own eyes. So
this is exactly the spirit of the conference, and frankly, I sign up myself for workshops in other functional programming languages every year just to give them a try. I've been attending F# recently just to learn about their approach. They have static typing, we have dynamic typing, just to get a feeling of how it feels when you develop, compile, and run a program in such a statically typed language. So exactly the spirit of the conference is something that you should take back home and try to get inspiration also in between projects, try to poke around in other lands.
Yeah, and as was all said, I mean, from a practical point of view, no language is good at everything.
Yeah.
And accept that fact, get over it, work with it, and make the best of it. And then you'll get the best of all sides, right? So even I can say it. I mean, Erlang in the beam is not good at everything. We accept that fact and work on. Right?
Yeah, and I think I attend any of the Erlang and Elixir conferences, and I think you'll see a lot of talks around polyglot programming, around using Rust and Elixir or Go and Erlang together for what they're good at. Not one or the other.
Yeah,
Right.
Most definitely.
Cool. We've got one question here, which I think is a good one to end on. So I think I'll get an answer from all of you on this. And then if there is anything that hasn't been answered, get it through to us on Twitter, and I'll see if I can get answers for the email that we send to you in the post. But to wrap up, I think this is a good one. What are each of you excited about in regards to the future of either Erlang or Elixir or both?
So
I'll start. So I think that live view is a system that's going to change a lot of things, and not really because of what's on top. We're all talking about what's on top, but I think that the reason that live view is interesting is that it maintains the abstractions all the way down. When I talked to Jose about live view, there's a story about the monk that says, well, the world is sitting on a turtle and the universe is sitting on, or the solar system is sitting on a turtle. And then somebody asked, well, so what about the universe? He says, oh, it's turtles all the way down. Well, Jose says that live view is interesting because it's turtles all the way down. It's the same abstraction. And then, so that means that the programming model is simple, understandable, and you get all of the power of the beam with something that where the programming, the web programming is seamless. You change something on the server and you see the web page update on the client. That's going to change a lot of things.
What I look forward very much into is the fact that both languages are going to share more and more infrastructure, by which I mean they can be more interoperable. As in, for example, documentation built in for one or the other language can be now brought into the shell or to the hex documentation in the same shape and form. There are other efforts on both communities and also within the OTP team at Ericsson that aim at bringing more common infrastructure streamlined, so that we can benefit from those two communities even within the same team, within the same project. And this is very encouraging.
Yeah, so I've seen Erlang go from a programming language to an ecosystem of programming languages. And it's not just Erlang or Elixir. There are many other Beam languages which are actually being used in production. And to add to what Michal said, it's not just the interaction of these of Erlang and Elixir mainly today and these other languages, but it's also how these new languages, these new ways of seeing things and doing things are helping the whole ecosystem evolve and are helping it, come to the next level. And what's really exciting me is I'm waiting for the next big language. We have Erlang and then Elixir. What's going to come after? What next language will become mainstream? After Elixir and be the new cool kid in town, which all of the startups want to jump on board and start using, as well as kind of enterprise companies, because these new languages, in order to be successful, must bring something new to the table, and it's this, and that's what really is going to excite me about it. It's what advantages, will they bring? What problems will they help fix? Which the current, which Erlang and Elixir currently can't fix.
Well, that's already happening. I mean, it's not like something, we're not talking about the future, we're talking about something that's being developed now.
Absolutely.
A number of different attempts to do things. I mean, one, for example, is static typing. How can we get static typing into the system in a nice, reasonable way? And there are a number of different things being done that. I don't know which one's going to win, so to speak, but someone will. That will introduce a nice new feature to the language, to the system as a whole, right?
And it will. And I can't wait for static typing. So we'll shut up everyone saying, "Oh, but we can't possibly use Erlang. It's too buggy, because of the dynamic typing, and and it's and you can tell them no. But that will at least get that group of skeptics out. I don't think they're going to start using these new languages, but at least we'll shut them up.
Yeah, they'll come more stuff. I mean, I think that's good. And as Michal was saying, just the fact that there's serious work being done in making sure they can interface with each other properly, and we can use one from the other and the other from one, so to speak, and not have to worry about things like that getting it to work. I think it's good. That will just strengthen the whole thing, right?
I think we're approaching 30 languages on the beam. So Bruce, I think. I think we're approaching that. Last count I had was 25, and that didn't include. Okay. So, I think, Bruce, that's a book for you. 30 languages in 30 weeks, 30 beam languages in 30. One to think about.
Yeah. Okay. I've missed a lot. There are many I've missed. Okay. Yeah.
Perfect.
Might need a co-author for that one, Francesco. So how hard do you really want to push this idea?
Yeah, no.
All right. Listen, thank you everyone for being part of this. I think I've had a great time sharing experiences and my views.
Yeah. Good. Thank you again, everybody, for presenting. Bruce, Tate, Michal, Slaski, Francesco, and thank you all for joining us. Our next webinar will be on Crawley, which is a framework which makes data scraping and web crawling possible in Elixir. Details to that, the recording of this webinar, and some links to other things that were spoken about will all be in your email next week. Until then, thank you all for being here, and thank you for presenting.
Thank you. Okay. Stay well. Stay safe.
Bye. Thank you.
Thank you.
Thanks.
Good. Thank you very much. Bye.